Okay, so today we are taking a look at the quadratic formula. So we've slowly been building up to this. We've looked at factoring case 1 and case 2. We've looked at completing the square. And now we are looking at the end-all be-all solution to finding the x-intercepts of a quadratic. So today we're taking a look at the quadratic formula. The quadratic formula is this: x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This quadratic formula is derived or developed from taking the standard form of a quadratic and completing the square. So what someone did, is they took ax squared plus bx plus c is equal to 0. They took this and they actually went ahead and did a completing the square of this standard form. So they went ahead and divided everything by a, and they got x squared plus b over a times x plus c over a is equal to 0, and then they moved this to the other side and then completed the square. And when they did that, they ended up with this. They ended up with a formula that all you have to do is take your b values, plug those in, take your a value, plug it in, take your c value, plug it in, and then just work this out. I will post a secondary video where I also go ahead and finish deriving the quadratic formula by completing the square, if you want to take a look at that. So why use the quadratic formula? Well, the reason that we would use the quadratic formula is that completing the square, although it always works, sometimes can give us some very weird numbers. When we take and divide the b value by 2 and then square it, and then sometimes you have to deal with an a value that you have to divide everything through, you can get some really weird fractions. And instead, we can just take and plug values into this and then just work that out. So here we have an example where we're going to use the quadratic equation. So the first thing we have to do when using the quadratic equation, or the quadratic formula, is make sure that we have it in standard form. So I need ax squared plus bx plus c. So I need to move this forward to the other side. So you would go ahead and subtract that. You have 2x squared minus x minus 4 is equal to 0. So now this is in standard form. This is my a value, this is my b value, and this is my c value. So we're going to take those and plug those into x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we have x equals, we're going to replace this b with my b value right here, which is a negative 1. Then we have the plus or minus, which this plus or minus comes from when you take the square root, you have the positive and negative variations. My b value was a negative 1, so we're going to have negative 1 squared minus 4 times my a value, which the a value in this is 2, multiplied by the c value, which is a negative 4, and then all of this will be divided by 2 times my a value, which is 2. So now we just go ahead and work this out. And usually the way that I focus on working this out, I'm going to deal with if I have anything here in front of the plus or minus. So you have x is equal to, well, negative times a negative gives you a positive 1, plus or minus our square root, and then I'm going to work on everything on the inside of my square root. So the first thing I have to do is take this negative 1 and square it, which gives you a positive 1, and then we're going to take and multiply out this negative 4, 2, and a negative 4. We need to remember that this negative goes with the 4, so it's negative 4 times 2, which gives you a negative 8, and then you take a negative 8 times a negative 4, which should give you a positive 32. So 4 times 2 gives you 8 times 4 gives you 32. And then in the bottom, we have this 2 times 2, which is just going to be 4. So now I can go ahead and say x is equal to 1 plus or minus the square root. Well, 1 plus 32 is 33. And then this is over 4. And then I look at this and I see if I can simplify. There's nothing I can do with the square root of 33. So because there's nothing I can do with the square root of 33, it's just going to stay like this. If this was a perfect square, or if I could simplify my radical, then I would do that and then look about doing a little bit extra work. But unfortunately, I cannot. So this is where I would stop. So here's another example. Now we have x squared minus 3x plus 5 is equal to 0. This is obviously something that we could not factor because nothing multiplies to give us 5 and adds to give us a negative 3. Generally, we still want to look and see if we can factor because factoring is still going to be quicker. So x is equal to a negative b value, which is, in this case, a negative 3, plus or minus the square root of our b value squared minus 4 times my a value, which is 1, times my c value, which is 5. All of this over 2 times my a value, which is 1. So we'll go ahead and start working this out. So negative times a negative again gives us a positive 3 plus or minus our square roots. Negative 3 squared gives me a positive 9. Negative 4 times 1 times 5 gives me a negative 20. And then 2 times 1 is just going to be 2. So we end up on the next step getting x is equal to 3 plus or minus, well, we have the square root of 9 minus 20, which gives us negative 11 over 2. So now when we get to this step, there's nothing I can do, but also if we look at our square roots, or the number inside of our radical, we have a negative 11. We cannot get real results when we have a negative square root. So for this case, this is going to technically be an imaginary solution, so this would give us no real solutions, which means that for this, we are not going to cross the x-intercept. Which brings us to the next thing. So we have something that is called the discriminant. What the discriminant is going to be just the value that is left underneath the square root, the b squared minus 4ac. If you take the discriminant and calculate the discriminant, if you get one real root, or one answer, so in the case that b squared minus 4ac is 0, what happens is we have one real root, which means that on your graph, you touch the x-axis exactly once. If we take the discriminant and we get a number that is larger than 1, then what that means is that I have 2 real roots, and that means that I pass through the x-intercept twice. If we have a negative number for the discriminant, that means we have no real roots, which means that our graph wouldn't touch the x-axis. It's either above or below, and it's going in a direction such that it's either above and opens up, or it's below the graph and it opens down, and therefore never crosses the x-axis. And then the very simple version is, and what this usually means is, if you have a perfect square for your discriminant, odds are you probably should have factored it, because that problem is actually factorable and would have been probably quicker to solve by factoring. So for the discriminant, sometimes we'll calculate just the discriminant to determine how many solutions we have. If the discriminant is 0, you have one solution, touches the x-axis once. If you have anything that's a positive discriminant, it means you can take the square root, and therefore you can add or subtract, and you get 2 x-intercepts. If it is less than 0, or a negative number, what that means is that you're taking the square root of a negative number, which is not real, it's an imaginary solution, and that means that you are never going to touch the x-axis. So here we want to go ahead and try and determine what are the number of real solutions for both of these. So when we want to determine the number of solutions, we don't actually have to do the full quadratic formula. All we need to do is take the discriminant, which is this b squared minus 4ac. So we're just going to do b squared minus 4ac and work that out. So my b value is 14. So we have 14 squared minus 4 times my a value is a -1. Something that I should have looked at before I started this is that this is not in standard form. So technically this 49 needs to be moved to the other side. So this would actually be a -49. So -49, and then that would be equal to 0. So now my c value is a -49. And then we would just go ahead and work this out. And then depending on what I get for the discriminant tells me how many solutions I actually have. So when we do 14 times 14, we should get 196. Then when we do 49, and we have a bunch of negatives that we're going to deal with, but we have 49 times 4. So we have 1, 2, 3 negatives. So when you multiply 3 negatives together, you end up with a negative number. So -4 times -49 gives you a positive 196, but then this other one flips it back to a negative. So you have 196 minus 196, which gives you 0. So because I have a discriminant of 0, that means that I have one real solution. So if I were to find the x-intercepts for this problem, I would only find one of them. So here's another example. We have the b squared minus 4ac. So we're going to take -3 squared minus 4 times 2 times 7. So we have 9 minus, and then we're going to do a -4 times 2, which gives us 8. And then you take 8 times 7, which gives you 56. So we end up with a -56. And to be completely honest, at this point, we could go ahead and work this out the rest of the way, and we could get a -47. But generally speaking, unless it asks for the discriminant, if it only wants the number of solutions, immediately at this step I kind of know what's going to happen, because you're going to end up with a negative number. And anytime you end up with a negative number, you have 0 real solutions. Because what you're trying to do is you are trying to take the square root of a negative number, and square roots of negative numbers are always going to be imaginary. So that covers most of the stuff we have with the quadratic formula. Quadratic formula is just kind of plug and chug, and you just work it out. As I mentioned, I will have another video in which I actually go through and derive the quadratic formula from standard form.